Okay, I thought I'd take a minute and record a video and just show you what you can do with your phone. Again, I've got a camera. I don't mind you're using that camera. But I'm going to do a little over 2 minute video just talking about Ohm's Law. And again, this needs to be some concept that you learned at some point in your time out here, or maybe one you had to learn to make this video. But again, I don't want you spending a lot of time. So we're at about 30 seconds now. So I'm going to go ahead and get started with what would be my real video. So this is the Ohm's Law chart here, and we see that E, which is represented as voltage over I times R, is the formula in Ohm's Law. And basically we can cover up whichever one of these, and E can be substituted with V. We know those two are sometimes interchangeable. So it kind of depends on which text you're using, whether you see E equals I times R, or if I cover up I, that's E over R, or if I cover up R, that's E over I, and if I cover up E, that's I times R. And again, you see how my video is going, so that's why I'm saying it doesn't have to be perfect. So anyway, to solve this simple series circuit, I've got a 20 ohm, a 30 ohm, and a 40 ohm. The very first thing I have got to come up with is, well, we know our voltage, V total, right here, and I'm coming over here to the right and I'm writing, is 20 volts. And again, you could do this on a piece of paper. It doesn't have to be on the screen. I'm just choosing to do that because that's right in front of me. So R total, because this is just a simple series circuit, all I got to do is add them all up. And so if I take a 20 and a 30, that's 50, and I add 40 more, that's 90 ohms. So there's 90 ohms. So now I need to solve for current. I've got my V total, which is same as E, and I'll write E above that. Again, those two are interchangeable. It really doesn't matter if we use E or V. So now I'm wanting I. So I is found by E over R. So I've got to take this 20 volts, so I total equals 20 volts over 90 ohms. Now, I can't do that math in my head. I could get a fraction. This IT is going to be 2/9, but if I want to pull up my calculator, I'll do that real quick, and you'll have to just bear with me with the video as I do that. But if I come down here and I say 20, and let's let you see the calculator, 20 divided by 90 equals, that's going to be equal to 0.222. So we'll come up here and we'll say equals 0.22 amps. And since this is repeating 2, I'll put a line over my 0.22. So inside of this circuit, and I'll even change a little color, is 0.22 amps. Wow, that's a sad looking arrow, isn't it? It's supposed to be something more like that. So 0.22 amps. Now if I want to get voltage drops, and I'm going to take my video a little bit longer, and that's okay. Remember, I said a minimum of 2 minutes. If I want to get voltage drops of R1, voltage drops of R2, and voltage drops of R3, it's just a matter of doing the math here. All we have to do is take the current through each one, and we know that's 0.22 times 20, so that's going to be 4.4 volts. 0.22 times 30, that's going to be 6.6 volts, and I can do that on the calculator, but so can you. And 40 times 2.2 is 8.8 volts. Now we know the sum of those drops should equal the applied voltage, 20 volts. See how close we are. 4 plus 6 is 10, plus 8 is 18. Carry the 1. 4 plus 6 plus 8 is 18. So we came out with 19.8 volts. So not bad, very close. and we proved Ohm's law in a simple series circuit. And there, sports fans, is almost a 4-minute video, not counting my other rhetoric. So shouldn't be a big deal for you to do something like this. Again, this could have been on a sheet of paper. But bottom line, this is kind of what I'm looking for. Thought I'd share one with you so you can see exactly what you need to be doing. It doesn't have to be Ohm's law. It can be something you learn on a robot. It can be something you learn in PLCs. It can be just something about navigating the course, whatever the case might be. But I'm looking for accurate content just as you see here. Thanks.